Hi, this is Mrs. Yabut. Our lesson is about equation of circles, and today you're going to learn how to use the completing the square method in finding the equation of circles in standard form. We complete the square and quadratics that are equations for the graphs of parabolas as well as equations that represent circles. Completing the square will help us easily see the vertices of parabolas and determine the centers and radii of circles. This lesson will focus on completing squares for circles. Given a circle in a coordinate plane with equation x plus 2 enclosed in a parenthesis squared plus y plus 1 enclosed in a parenthesis squared is equal to 9. Looking at the graph, we can identify that the center is located at -2, -1, while the length of the radius, if you count out from the center to any point on the circle, is 3 units long. Now, do you see any relationship between the center of the circle and the equation? And if you say that the center corresponds to the value inside the parentheses of the equation, you got it right. Also, do you see any relationship between the length of the radius and the equation? You're right. The radius is the square root of the constant in the equation. The standard equation of a circle is given as x minus h enclosed in a parenthesis squared plus y minus k enclosed in a parenthesis squared is equal to r squared, where the negative signs are part of the formula and not the sign of h and k. Now, applying what we have observed in the previous slide, your center corresponds to the numbers that are being subtracted or added inside the parentheses. So in example number 1, our center would be 4 and 7. And the radius is the square root of the constant that we have in the equation. In this case, the radius would be 2. And doing example number 2, if you say that the center is at -1, +6, you got it right. And the radius would be the square root of 1, which is 1. Now it's your turn. Find the center and radius from each equation of a circle, and you may check your answer in the next slide. Now let's check your answer. For number 1, the center is at +3, +3, and the radius is 5. Number 2, the center is at -4 and +1, radius is 4. Number 3, the center is at -5, 0, and the radius is 6. And for number 4, the center is at the origin, 0, 0, and the radius is 2 square root of 5. Sometimes the equation of circles are not in standard form. For example, if we have x squared plus y squared plus 4x minus 6y equals to 3, it's not in standard form. We must use the technique called completing the square to rewrite the equation in standard form, where we will have a open bracket x squared plus bx over a plus open bracket b over 2 raised to the second power close bracket plus c equals 0. Looks complicated, but don't worry, it is not. Now let's go back to our example. X squared plus y squared plus 4x minus 6y equals 3. Our first step would be to isolate the constant term. In our case, ours already is. But in the case that you have constant with the variables, all you got to do is eliminate it by isolating it to the other side of the equation. For step number 2, we got to put parentheses around our terms with the same variables. In this case, we have x squared plus 4x as one group and plus y squared minus 6y as the other group equals to 3. For step number 3, we make sure the coefficient of each squared term is 1. If it isn't, factor the value out of its expression. In our case again, we have 1 as the coefficient for both terms that are squared. And that's for the case for any circle. It is always 1. For fourth step, we are to complete the square by dividing our b in each expression by 2, then squaring it and adding it to each of the expression. For the group of x squared plus 4x, our b is 4. Dividing 4 by 2 will give us 2, and squaring it will be 4 again. So we're going to add 4 to x squared plus 4x, and then plus 4. For the second group, our b is a negative 6. Dividing it by 2 is negative 3. Squaring it will give us a positive 9. So y squared minus 6y plus 9. Now, what you add on one side should be added on the other side. That's why you will see on our right side of the equation, we have 3 plus 4 plus 9, since we added 4 and 9 on each of our groups. For the last step, simplify both sides of the equation by factoring the quantities and adding the constants. You will have x plus 2 enclosed in a parenthesis to the second power plus y minus 3 enclosed in parenthesis raised to the second power equals to 16. Now you have the equation of a circle written in standard form. The center would be negative 2 and positive 3, and the radius is equal to 4 units. Now it's your turn to try one. Now think, pair, and share. Find the center and the radius of the circle with the equation x squared plus 2x plus y squared minus 4y plus 4 equals 0, and then sketch its graph.